I have two more sections. One is very short. It's ESD test. I'm not sure if anyone has to do that. I just say a couple of words about it. We always had that capability coming from Altium, doing ESD tests. We used a circuit for that, which was directly connected to our PCB. That means we have a direct connection. The test is contact discharge. Two switches, one is opening to charge the capacitor, and then the other one is opening to unleash the discharge of the capacitor of the energy to the board. The board is directly in 3D connected, and that workflow can be used for example, test different things. Like, for example, what am I doing with a different grounding scenario? What am I doing with if I place a varistor? Or how can ferrite beds help my design? So this is a very good way of being very structured, analyzing and being repeatable on different results, and then improving the design towards ESD. Since 1 year or 1.5 years, we have a workflow and a solver technology which combines nonlinear air chemistry with electromagnetics. And that means we can also do air charge or discharge type of ESD tests. The tool does something smart in the background. It understands the probability in each element if there is a breakdown, and then changes the conductivity of that little element in the air to very high so that the current flow can happen. And the workflow is very nice in terms of also adapting to your curves. And as you can see here, you move your PCB in from Altium, you specify the region that is that nonlinear air chemistry and the electromagnetics happening. The round tip will then help to distribute the arc. It's a transient simulation, and you can then move the tip over your PCB in different directions and different locations to see what's going to happen. And the post-processing we do usually there is looking at the E-fields, but also looking at the voltage that is coupled into the trace by terminating the traces with a 50 ohm resistor or something like that, and then understanding what my voltage is in there.